The question is, the trigonometric Fourier series for the waveform f of t shown below contains, the waveform is as shown, and the options are: first option, only cosine terms and 0 value for the DC component; second option, only cosine terms and a positive value for the DC component; only cosine terms and a negative value for the DC component; last option, only sine terms and a negative value for the DC component. Now we see the solution of this question. Now for any signal x of t, the Fourier series expansion is given by a naught plus summation of n equal to 1 to infinity an cos of n omega naught t plus bn sin of n omega naught t, and the values of a naught, an and bn can be found by the equations which are written, that is a naught equal to 1 by t integral over some fundamental period t naught of x of t dt, and an equal to 2 by t integral over some fundamental period t naught x of t into cos of n omega naught t dt, and bn equal to 2 by t times of integration over an fundamental period t naught x of t into sin of n omega t dt. Now the given function f of t is clearly an even function, and it is asked whether in the Fourier series expansion there are only cosine terms or only sine terms. Consider this equation. Since x of t which is given is even function and sin of n omega naught t is an odd function, x of t in sin of n omega t is an odd function. Therefore, when an odd function is integrated over a fundamental period t naught, then the value of that integral is 0. So therefore bn equal to 0. Substituting bn equal to 0 in the Fourier series expansion, we can see that we have only the cosine terms and the sine terms are 0. Now we need to find the value of the DC component, that is whether it is negative or positive. Now the DC value is given by a naught equal to 1 by t some fundamental period t naught of x of t into dt, that is we are integrating x of t over a fundamental period t naught. Let us take the fundamental period is from minus t by 4 to 3t by 4. Therefore the integral becomes from minus t by 4 to 3t by 4 of x of t dt. From this graph we can clearly see that from minus t by 4 to t by 4 the value of f of t is a, and from t by 4 to 3t by 4 it is minus 2a. Substituting values of the x of t, evaluating the given integral, we got this t by 2 because integral of a constant function is nothing but the same variable, and substituting the limits we get this t by 2. Similarly here we get 2t by 4, and this evaluates as, and this sums as minus a by 2, which is a negative value. So trigonometric Fourier series expansion of the given function contains only cosine terms and a negative value for the DC component. So the final answer is C.